We've reached lesson 8 of the chemical bonding storyline. Chemical bonding storyline titled, Why Do Some Things Get Colder or Hotter When They React? The first half of this chemical bonding storyline centered around 7 lessons. The power of this storyline, as in any storyline, is that all these 7 lessons are connected to each other in a logical way. Part 2 of the bonding storyline does not so much center around reactions that feel colder, but instead this part of the storyline centers around reactions that are exothermic, that release heat. Lesson 8 of this second part of the bonding storyline is titled, Do All Complex Reactions Absorb Energy and Make Their Environment Colder? As you can see from this GIF animation of the reaction between potassium and water, clearly results in the release of energy. This lesson only took about 1.5 class periods or lab periods. My lessons are about 50 minutes long, so 50 plus half of 50, that's about 75 minutes. When did I teach this lesson? At the end of quarter 2. After my students added either potassium or sodium to water under my careful supervision, they modeled this very reaction using colored ion cards. I also had them use magnets to model this reaction, including this blue one to model sodium, emphasizing here that sodium is connected using metallic bonds. And they also used magnetic water molecules, which are connected using hydrogen forces. The products that are formed as a result of this reaction include sodium hydroxide, and that connection emphasizes an ionic bond. The second product that is formed is hydrogen gas, as was evident from the fizzing during this reaction. The hydrogen atoms connected through covalent bonds. This was a great board activity after I took these pictures on my phone, and students then walked up to actually label the specific bonds for the reactants and the products. But now let's focus on the sodium atoms. There's a very thin line that shows that this connection is a relatively weak metallic bond. On the product side, the connection between the sodium cations and hydroxide anions show you a much stronger, thicker teal line, highlighting that the strength of this product bond is much enhanced, which is the key reason that this reaction is exothermic. Stronger product bonds were formed after weaker reactant bonds were broken. The same activity could be done for potassium. Group 1 metal reacts in a very similar way, now modeled with the green, larger magnet, because potassium has 4 electron shells, whereas sodium only has 3 electron shells. And you can therefore review the trends of atom size in the periodic table. As you go down group 1, atoms tend to get bigger because the number of shells increases. Now we can model this very reaction using the blowtorches. Relatively weak bonds are broken. In particular, I'm focusing on the metallic bonds, in this case between the potassium atoms. That results in a transition state where the only way forward is to form new bonds. As reflected here, stronger bonds are formed between potassium and hydroxide, and obviously somewhat weaker bonds between the hydrogen atoms, and the concomitant energy release as shown by the 2 blowtorches. So to really finish up this lesson, I take my students back to the driving question boards. And I'm showing you here all the questions that they've shared with me, but I'll highlight a few that were particularly interesting. The first one is, which types of reactions are more spontaneous? The ones that cause a temperature decrease or the ones that cause a temperature increase? Good question. Question number 4. What a fun question this is. How large of an exothermic reaction would have to occur to boil the Earth's oceans? No idea. Number 7. Why are sodium and potassium interchangeably reacting in the same way? I wonder why. Number 10. Which types of reactions are able to be reversed? We're starting to think about Le Chatelier. 11. How do you calculate the amount of energy needed to break or create bonds? Are we delving deeper into thermochemistry here? Stay tuned for lesson number 9, Why do some reactions warm things up? In this lesson, students are modeling not the breaking, but the making of chemical bonds. And we're using the same setup as before, modeled during lesson 5, using the ramp, the magnetic and non-metallic marbles, as well as the speedometer. There will be updated student videos modeling this very setup. As always, the bonding storyline lessons follow the Next Gen Science standards as well as the New York State Science Learning Standards, centered around matter, and its interactions, as well as energy change in components of a system. I have chronicled all the lessons that pertain to Part 1. Check out the playlist called Stunning Storyline to watch all these lessons if you're considering to implement them with your chemistry students. This was the first lesson of Part 2, Lesson 8. If you're interested in any of the handouts and associated teacher keys, then click on the link in the video description below. In exchange for your email, that link will take you to a Google document that has all these resources at the ready. Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video. Clearly not.